All right, we've made it to the final part of our series. And now we're tackling the big one. We know all about how these solar particles can wreak havoc on our tech, but what are we actually doing about it? Let's dive into how we fight back and what the future challenges are for protecting our digital world. So, just as a quick reminder, this is the fifth and final installment of our deep dive. And it's all based on that incredibly detailed report, real world examples of the negative effects of solar high energy particles causing single event upsets on Earth based systems, which was put together by the RFI detectives over at Virtualization Options LLC. So here's the real dilemma we're facing. Our entire modern world, everything from the massive power grids to the smartphone right there in your pocket, it all depends on these unbelievably delicate electronics. So the question is, how on earth do we defend this fragile ecosystem from a constant storm of high-energy particles shooting at us from space? Well, it turns out we've gotten pretty clever about it. We've actually developed a really sophisticated, multi-layered defense system. You can almost think of it as high-tech armor for all our critical infrastructure. So let's break down the three main layers of that armor. Our digital shield, if you want to call it that, is really built on three core strategies. First up, you've got hardware hardening. That's literally about building tougher, more resilient computer chips from the ground up. Then there's software fault tolerance, which is all about writing smarter code that can actually spot and fix errors as they happen. And finally, we have smart operations, which is about having people and systems ready to react to space weather threats in real time. Now, this is where it gets really interesting, because there are trade-offs with every approach. Hardware hardening, making tougher chips, it's our most direct defense, but wow, is it expensive? And it's almost always a few generations behind the latest commercial tech. Then you have software. Think of error-correcting codes, or ECC, as a kind of built-in spell check for your data that's constantly looking for and fixing these little bit flips. Or triple modular redundancy, where a system literally does the same job 3 times and then takes a majority vote on the right answer. Super effective, but as you can see, it makes things more complex, and it definitely eats up processing power. And lastly, those operational procedures are absolutely crucial, but they depend on space weather forecasts that, let's be honest, can be imperfect and often give us very little warning. And this picture perfectly illustrates that third layer of defense in action. A huge part of this strategy is having human experts in control rooms, just like this, watching the space weather data 24/7. The second a threat pops up, they can jump into action. Maybe they put a satellite into safe mode, or tell airlines to reroute flights away from the poles, all to protect our most critical systems. But, and this is a big but, there's a major twist in this story. Just as we're getting better at defending our technology, the very nature of that technology is changing. Our greatest strength, making everything smaller, faster, more powerful, is also, weirdly enough, becoming a huge vulnerability. Just think about it. The phone in your pocket has more computing power than what it took to get us to the moon. And that's because we've figured out how to cram billions, literally billions, of transistors onto a chip the size of your fingernail. This relentless drive for miniaturization is what powers our modern world. And this leads us to what's known as the miniaturization paradox. It's fascinating and, to be honest, a little bit scary. As these transistors get smaller and smaller, the amount of energy it takes to flip one of their bits from a 1 to a 0 gets smaller too. That means our newest, fastest, most powerful chips are ironically more sensitive to a wider range of cosmic rays, even the lower energy ones that older, clunkier tech could just shrug off without a problem. So with every new generation of technology, we get these devices that are just exponentially more powerful and way more energy efficient. But we're paying for it with resilience. Every huge leap forward in performance is also making our technology more fragile and more susceptible to these cosmic glitches. So, our tech is getting more vulnerable from the inside out. But what about our protection from the outside in? Well, it turns out our planet's own natural force field is facing its own long-term challenge. Yeah, check this out. A 2024 study in the Proceedings of the National Academy of Sciences found that Earth's magnetic field, our #1 defense against solar radiation, is actually getting weaker over time. The study's conclusion is pretty stark. In the future, the exact same solar storm we deal with today would cause much, much more damage on a planet with a weaker shield. And why is that such a big deal? Well, because in our modern world, everything is connected. A single cosmic ray causing a tiny glitch in one power grid computer could, in theory, trigger a chain reaction, a cascading failure that brings down communication networks, messes up transportation. You get the idea. A weaker planetary shield just means there's a higher chance of that first domino falling. So when you put it all together, our tech is getting more fragile and the planet's shield is getting weaker, it becomes pretty clear that we have to start thinking bigger. The old ways aren't going to be enough. So what's the path forward? When you talk to the experts, to organizations like COSPAR and ISWAT, they are all crystal clear on this. The only way we're going to handle this is by working together. We're talking about robust international data sharing so everybody has the best possible space weather forecasts. We're talking about coordinated scientific research so we can pool our brainpower to invent better ways to protect our stuff. And we need to create global resilience standards so that our interconnected systems are all protected to the same high level. At the end of the day, the core takeaway is simple. Solar storms are a global problem. They don't check passports, they don't care about national borders. And because of that, no single country, no matter how powerful, can protect itself all alone. Our defense has to be just as borderless as the threat itself. And that leaves us with one final thought, doesn't it? The very same technology that makes us so vulnerable to space weather is also the technology that connects all of us as a single global community. The real question is, can we use that connection to unite and build a future that's truly resilient for all of us?